All right, so let's use the bookshop dataset in Tableau to start making some recommendations. So at some point, we really want to leverage the insights that we've made in order to influence future decisions. Not necessarily understand the past, but also kind of like what should we do? And to do this, we really do need to kind of understand what the data is telling us in a particular area, so that we can then kind of port that over to the future. So, for instance, imagine we are let's say trying to launch a new book, and we're trying to decide what the price point of that book should be. So we know that as the price changes, the number of units that we sell will also change. This is just classic like elasticity of demand from economics. Typically the higher the price, the lower the demand. That's the general idea. Although there's, not always. There are some things that are not so elastic. But anyways, let's see what happens here. So let's make a new sheet. And in order to decide what the price should be, we need to get the price in there. So let's drag price to columns. If you're from an economics background, I know this is strange, but in a business context, the price is the thing that we can set as the business owner, and therefore we should really think about it as the independent variable. Whereas in economics, we think of price as the dependent variable, the thing that's set by various levels of supply and demand. But kind of in business, it's a little bit backwards. Regardless, you'll get the same plot. It'll just be flipped, but it's really up to you. So we'll do price on our independent axis, our horizontal axis, and then I want, let's go down to sales, and let's just do total sales right now. So notice when I do this, I just get one data point, and that's because everything's been aggregated down. Notice the sum here is and the price here is the sum of the price, and the sales is the count of the sales. And so right now, the visualization's level of detail is all the way at the top of the data set. This is boiling the entire data set down into just one data point. But that's clearly not what we want, right? We really do have to decide what we want the level of detail of this visualization to be in order to best make the case, or best answer the question, or best explore the topic that we're interested in. So in this case, we want each one of these dots to be a book, like to be each individual book. And in order to do that, we just need to drag the book, anything about the book really, but the title is the easiest, onto detail. And in that way, now each one of these dots you can verify is a different book. Each book has a price, and each book has a sales volume, how many units we've sold of that book. Now the question is, what do we make of this blob? There's a huge mess of points here, and the question is, well, how do I interpret this and what do I do with it? The most straightforward way to start analyzing this is just with a trend line, which tries to linearly relate the price that you charge to the number of units that you sell. And so to do this in Tableau, you just simply right-click and go to Trend Lines, Show Trend Lines. Now it pops up. So this is the normal linear regression, the line of best fit, the ordinary least squares solution. It goes by a lot of names, but basically it's the best linear approximation of how the sales volume, the number of units that we sell, is related to price. We can actually see the equation itself if we hover over. And so what this is saying is that for each, so the equation is the first line, for each increase of price by $1, the number of units sold on average, everything else equal, goes up by about 10.5. That I can't move my mouse to show you because it won't hover over anymore and it will lose it. But you see there's that 10.46 thing times price. That 10.46 is the sensitivity itself. And what that's saying is as price goes up by 1, the demand for the book goes up by 10. And so the question is, what the heck is going on, right? That doesn't seem right. Most products don't behave this way, in the sense that if price goes up, typically demand goes down. So how are we supposed to interpret this? Well, there's an additional piece of information here that we should be concerned about. There's actually two. Let's start with the p-value, the last one. So if you remember from statistics, the p-value represents how likely it would be to observe data like this if there were actually no relationship between the two things you were trying to relate. In this case, price and the sales count. So what this is saying is we would expect to see data like this, or more extreme, 45% of the time, if in fact there were no relationship between price and count. What this is saying in a nutshell is that it's entirely likely that this data is just random, that there's actually no linear relationship between the input and the output, the price and the demand. So there's no reason to believe that this line is meaningful, in other words, which is just both surprising. I mean, it's a line, it's there, it can always get made, but at the same time, it disagrees with our intuition about how price and demand work, and therefore maybe we shouldn't be surprised if it's not a super great fit. How can we describe how good of a fit it is? It's the middle line, the R squared. So this in some sense is the percentage of the variation in the data that's explained by the model. So what we're seeing here is of all the variability in this point cloud, of all the scatter in these lines, in these points, how much does the line account for? Just over 1% of the total variation. In other words, it's a really crappy model. It's not explaining much of what we're seeing at all. Why might this be? Well, it's hard to say. So there's a couple hypotheses. One is that there's just not a relationship between price and demand in this model. It's just not really that just doesn't make sense to say that. Like price really doesn't impact the number of units we sell. And maybe that's the case in our industry. I don't know. It's hard to say. The other thing is that we might be getting pulled around by outliers. So for instance, see this guy up here? This is a book for which we sold over 7,000 units, way more units than any other book, and it was super expensive. It was almost $67 for a single book, and we sold 7,000 units of this thing. I think we can all agree that's strange. That it's an expensive book, $67, and in particular, it's way more expensive than any other book, right? The next most expensive book in this data set is just under 50. Okay, so it's like 15% higher than that, and we sold way more units. Like the other one was about 4,600. This one's over 7,000. I mean, this is very clearly a strange book. So maybe, just maybe, if we're trying to detect statistical regularities in this data set, we should exclude this data point from our analysis. And let's see. So let's click on the data point itself and say exclude. Notice what happened here. This completely changed the picture. I went from thinking there was a positive relationship between price and sales count, meaning as I increased price, sales count went up, to thinking there is a negative relationship between price and sales count, meaning as I increase price, sales count goes down. This is much more what we would expect from the classical economics literature. So this is much more in agreement with, I think, your intuition and my intuition about how these things should work. So if I hover over here, now I'm saying that for every additional increase in price by 1, on average, price goes down by, sales count goes down by 15 units. And notice that this is not that much better. So the issue here now is that the p-value is 0.21, which is saying there's a 21% chance that we would see data like this if there were no relationship between the input and the output, between the price and the sales count. It's entirely possible that this is just a random scattering of data points that has nothing to do with anything. And it only explains about 3% of the total variability in the data set. So, I mean, you can keep going through this where you might say, well, what if we exclude these? Like, is that gonna do something good for us? You know, like we can. But you get into a really gnarly area here, which is like, well, what do you choose to keep and what do you choose to throw away? So you might select here, just select these and say, okay, for books like this, notice if I select, I get a new trend line, and that trend line explains 15% of the variability of those data points and a p-value that's quite low. So it's very unlikely that what we're observing here is just due to chance, just due to randomness. The question is, can you, in good conscience, in your particular application, justify that these things are not typical? That's the case you have to make. You really have to make the case that these are outliers, that these are data points that are unlikely to be replicated. They're not indicative of most books. They're not indicative, for instance, of the book that we're trying to market. If you can make that case, then you're totally justified for throwing them away. You just have to be careful, because as we start to throw things out of the data set, we're seeing over and over again that it fundamentally changes our understanding of how the world works. And so there's this really dangerous place that we can get into where we start throwing away the data that disagrees with the way we want the world to work. And this can be really dangerous, not only because it's intellectually dishonest, we could be misleading people, but also because it could lead us into bad predictions. If we are throwing away data points that are actually quote unquote real, that really are describing how the world works, and we're making decisions based on the absence of those data points, we're just going to make crappy decisions. We're just going to make crappy decisions. I mean, you can imagine that this happens in financial crashes, for instance. If you just say, oh, those mortgages don't matter. Don't include them in your risk calculations. But if they are impacting the risk of your portfolio and you're not accounting for that, you could be in really bad shape. Or if you're saying, that demographic, our competitor will never get to that demographic. There's no way they're going to include that in their market share or capture that in their market share. If in fact they do, then you're in big time trouble. So it's hard. It's like fundamentally difficult to decide what should go in and what should go out, and what parts of data sets you should include in visualizations for public consumptions and which you can safely ignore. I wish I had more firm answers here, but I really don't. It's a kind of a case by case basis that we need to investigate one by one by one.